So Ed, you mentioned something about building prototypes and doing some modeling ahead of time, computer modeling and simulation. How important is that in developing the proof of concept?
Well, I think it's critical, I would say, and it's probably changed over the last couple of decades. I think when I started as an engineer, a lot of the computer modeling we did was a lot of times after the fact. We couldn't really use it as a design tool because it wasn't fast enough. You'd run an analysis that would run overnight, then see what you were gonna change, do that, et cetera. So it was kind of a long pole in the tent. Now, because things run so fast that obviously it doesn't cost anything to do your computer modeling. So, example would be like the automotive industry. They have to pass a crash test, but if they find out a problem during the crash test, that's a pretty expensive fix. If they can do a simulation of this, which is now possible, but again, 20 years ago was not particularly feasible to do. They can do a lot of these analyses now, identify problems earlier, and I think that's kind of a key thing. Is that the earlier you can identify a problem, it's kind of like a logarithmic scale. That the earlier you do it, the cheaper it's going to be, and if it of course, at the far end, you find a problem after the product's been released, you have to recall, service, et cetera, then it's exponentially more expensive. So getting computer analysis done first, but I think also now that prototyping's become more affordable, more widespread, getting physical parts as soon as possible makes a lot of sense as well.
How long does it take to make a physical part, like with the MakerBot, for example? If you're making, say, a real part, right?
It can still, several hours, but again, things are still limited by size on most of these systems. So overnight, you can usually get a physical model of almost anything that you want to do.